For more than 100 years, physics has been staring at this ghost in the machine, a total mystery. Well, a new framework called Triune Harmonic Dynamics is making a bold claim. It says it has the answer, and it comes with a set of really specific, testable predictions. So let's dig in and see what this is all about.
I mean, it's the fundamental question, isn't it? The biggest weirdness in all of quantum mechanics. At the tiniest levels, it really seems like reality just waits. It waits for us, an observer, to look at it before it decides what it's going to be. How on earth is that possible? This question right here is the very core of the quantum measurement problem.
Okay, so let's be clear. Modern physics is amazing at describing what happens when we take a measurement. We can predict the outcomes with just jaw-dropping accuracy. But what it's never been able to do is explain why. Why does it have to happen in the first place? So picture a particle just existing as this cloud of pure potential. It could be here, or maybe over there, spinning up, spinning down, all of those things at the exact same time. That cloud is what we call the wave function. But the instant you measure it, that whole cloud of possibilities just vanishes, and it collapses into one single real thing. The billion-dollar question has always been, what's the mechanism that forces that collapse?
Now, the solution being proposed here starts somewhere completely different. Not down in the quantum world, but with a pattern that's claimed to be, well, universal. A simple, repeating rhythm that might just be the actual blueprint for reality itself. This is the big question asked by the researcher and inventor behind this idea, Kevin L. Brown. He's basically suggesting that underneath all the seeming chaos of the universe, there's a kind of music playing, a fundamental rhythm that dictates how everything, from a single atom to an entire galaxy, changes and evolves.
And he calls this framework Triune Harmonic Dynamics, or THD for short. Now, this isn't just some philosophical musing. It's being presented as a mathematically solid and, most importantly, a falsifiable model. A model that says reality unfolds in this very specific 3-6-9 sequence.
So at the very heart of THD is this repeating three-step dance. First, you've got emergence. That's the birth of a new state, right? Think of a seed just starting to sprout. Second is contrast, where that new state gets tested and pushed around by opposing forces, that little sprout having to push through the dirt. And finally, you get integration, where everything resolves into a new, more stable reality, like that seed finally becoming a sapling. The claim is that this pattern is happening absolutely everywhere, all the time.
And this equation right here is the mathematical engine behind the whole theory. It's designed to precisely map that cycle of transformation we just talked about. See the numbers 3, 6, and 9 in there? They correspond directly to those phases: emergence, contrast, and integration. It's treating change not as some random event, but as a structured, almost musical progression. So, the big question: how does a universal pattern solve the quantum measurement problem? Well, THD offers up a completely new way of thinking about why that wave function has to collapse.
And here's the core idea. I want you to think of reality not as some big, empty stage, but more like a giant computer. And, like any computer, it has a finite amount of processing power. Every single thing that happens, every particle uses up some of those resources. So according to THD, when you have a particle existing in that fuzzy cloud of many potential states, and it interacts with an observer, which is in one single fixed state, that creates what's called informational pressure. It's kind of like trying to run way too many programs on your laptop at once. The whole system gets overloaded, and to stop itself from crashing, it is forced to resolve the conflict.
And that resolution happens through something the theory calls the 3-6-9 lock. You can think of it like a universal autosave function. The system starts in a low-cost, fuzzy probability state. That's emergence. Then, interaction with an observer creates that informational pressure. That's contrast. When the pressure hits a critical limit, the system snaps into a single, definite state. That's integration, all to save resources. Suddenly, the collapse isn't some magical event. It's just computational efficiency. Now look, a wild new idea is one thing. But for it to actually be science, you have to be able to test it. It needs to make predictions that could actually be proven wrong. And THD puts its money where its mouth is, with 3 very specific, very high-stakes tests.
Okay, first up is the latency of manifestation. Here's the logic. If the collapse is a computational process, it can't be instantaneous. There has to be a tiny, tiny processing lag or a rendering delay. So the prediction is that we should be able to detect a brief shimmer of instability right as the system resolves. And the test is beautifully simple. If that transition is perfectly instant with zero noise, the model is false. Done.
Prediction number 2, the Landauer heat spike. There's this fundamental rule in physics that says erasing information has to generate a tiny puff of heat. Well, when a wave function collapses, all those what-if possibilities get erased, leaving just one. So THD predicts this should release a real, measurable spike of heat at that exact point. And if there's no heat, that means the information that was erased wasn't physically real, and the model is wrong.
And third, we have informational drag. Now, this test suggests something really radical. What if the speed of light isn't just some cosmic speed limit, but it's actually the ultimate processing speed of the universe, its bandwidth? If that's true, then a region with a lot of informational pressure, like say inside a busy quantum computer, should create a kind of traffic jam. The prediction? The speed of light should actually slow down a tiny but measurable amount in that area. If it stays perfectly constant, then the whole resource management idea falls apart.
So let's just imagine for a second that these predictions actually hold up. The implications here would go way beyond any science lab. I mean, it would fundamentally change how we see reality and our role in it.
This completely reframes what an observer is. It suggests our consciousness isn't some strange, mystical force. Instead, an observer, and that could be a person or just a machine, acts more like a reference clock. By introducing a stable, fixed system into a fuzzy, probabilistic one, it forces reality to sync up, to phase lock, which then triggers that resource-saving collapse. And that leads to this final, really profound thought. If we can truly understand the mechanism of collapse, the basic rhythm of reality's autosave feature, what does that actually mean for our future? Are we just figuring out the rules of the game, or are we about to pick up the controller